two speakers, S1 and S2, are placed 11 meters apart and are connected to a signal generator producing sound of wavelength 2 meters. The sound waves emitted by S1 and S2 are in phase. Point X is 5 meters from S1 and 6 meters from S2. So let's draw that on our diagram. The distance from S1 to X is 5 meters, and then the distance from X to S2 would be 6 meters. And then the question says, which of the following best describes the phase relationship between the sound waves received from the speakers at point X? So to work out the phase relationship, we first have to work out what the path difference would be. So the path difference is the difference in distance traveled by the two waves. We know that the distance S2 to X is 6 meters, and the distance from S1 to X is 5 meters. Take the two things away. So 6 meters minus 5 meters, that gives us the path difference of 1 meter. We know what the wavelength is as well. The wavelength is equal to 2 meters. So that means that this distance here is longer than this distance by half a wavelength. If we were to do 1 meter, the path difference divided by 2 meters, that gives us a half. So if one path is longer by half a wavelength, that would mean the phase difference is going to be pi. If you remember that one wavelength corresponds to a phase difference of 2 pi. So if you have a path difference of 1 lambda, the phase difference is 2 pi. So if you have a path difference of a half lambda, the phase difference is then pi. And if that's the case, the two waves are said to be in antiphase. So the answer would be C. Antiphase is specifically when the path difference is pi, or 180 degrees.